So, hello everyone. In this video, we are going to discuss about a specific topic. Short video I am preparing on Martite. You must have noted in BIF terrain, especially whoever worked, you might have noticed there are two hybrid things. Sometimes you might have come across when by seeing the rock, it will be just like hematite. It will be giving cherry red streak, but by seeing whenever you will be trying to use that Brunton compass, it will be deflected because of magnetism. So that magnetic property, hematite don't have. So definitely there are some magnetite as well. Now primarily magnetite and hematite in a same process cannot occur, cannot form. So there are some secondary process into which partial pseudomorph of magnetite by hematite occur. That is called martite. So by observing those kinds of hybrid property in BIF terrain, I am sure you might have come across same thing. So you can have idea on presence of martite. Further, after making that preparation of slides, thin section or close observation, you can also further confirm presence of martite. Before that, why martite is a secondary phenomena? Because magnetite and hematite don't usually form together. If we see this fugacity versus temperature, so stability field diagram itself indicate hematite, magnetite, oostite and native iron. All these iron oxides and native iron have different stability ranges. So hematite is occurring in maximum oxidized environment, high fugacity of oxygen than magnetite. Magnetite is in between. So hematite means what? Fe3O4 or Fe2O3. Hematite is Fe2O3 and magnetite is Fe3O4. Try to understand. So Fe3O4 means Fe2O3 plus FeO. Okay. So in magnetite, iron is in two different valence states, +2 and +3. Whereas in hematite, all irons are in +3 states. So when it is oxidized, magnetite is totally oxidized, it forms hematite. But in case of martite, few magnetite also left behind. And oostite is FeO. Okay. So these things if you see, now if hematite is stable under high fugacity than magnetite, as I have already mentioned, but lower than other silicates or like siderite or carbonate. Okay. So iron silicate, iron carbonate forms in mostly very low oxygen fugacity environment. Magnetite in between and hematite is high oxygen fugacity, that is oxidized condition. So at a given temperature pressure condition, only one of them will be thermodynamically stable depending on the exact redox states. Now magnetite therefore is a mixed valence oxide with formula of Fe3O4, as I have mentioned already. It contains both Fe2 plus Fe3 plus. Okay. It forms when conditions are not oxidizing enough to push all Fe2 plus into Fe3 plus. But exactly it is not under reducing as well, because in reducing condition Fe occurs as Fe2 plus like oostite or carbonates and sometimes iron silicates. But what is martite exactly? If we see, although hematite and magnetite are usually not stable together in equilibrium condition, but there are certain secondary process that is called martitization, in which hematite pseudomorph form after magnetite. So overall outline crystallinity wise it is appearing just like magnetite, but when you will make streak, it will give red, cherry red streak. That means it is already converted into hematite, but still it contains certain magnetic property. Okay, due to presence of magnetite in the core portion. Totally martitization if happen, then those kinds of hybrid things formed. So overall it forms when magnetite is oxidized to hematite. Again I am repeating, but the crystal preserves the original octahedral habit of magnetite. Try to remember these things. So these things are common in supergene oxidation zone of iron ores. So therefore always remember, in field if you get cherry red streak as well as magnetic property. Cherry red streak is characteristic feature of hematite because magnetite usually give black streak. But when you try to measure, take reading, see deflection of Brunton. So certain magnetic properties are also inherent in that rock. So magnetic property is given by only magnetite, not hematite. But steady red streak is given by hematite. So some BIF show both because of coexisting hematite and magnetite. Of course, as I have told, magnetite and hematite cannot form by a single process primarily. So recording these records fluctuating oxidation condition, correct? So how magnetite and hematite coexist exactly? What are the exact mechanisms? See here, this reaction, try to remember, Fe3O4 plus O2, entire thing become Fe2O3. So here plus 2 plus 3, both the valence states occurring in case of magnetite. When it will be converted into hematite, all will be in plus 3 states. So this happens in weathering zone above water table in iron ore deposits, and this lead to soft porous reddish martite retaining the original magnetite crystal form. Circulating oxygen rich groundwater reacts with magnetite. This is simplified. Apart from that simple supergene oxidation near surface environment weathering condition, there are other phenomena as well which can also lead to form martite, like diagenetic low grade metamorphic oxidation or sometimes hydrothermal oxidation. Now point is that, what is the geological importance of martite? Martite is a diagnostic product of oxidation in many high grade iron ore deposits. See, hematite is more important than magnetite as far as iron ore is concerned. So it indicates supergene enrichment and upgrading of BIF into ore. Okay, so it records also paleo-oxygenation condition. Martitization reflects oxidative weathering episodes. And texturally, as I have mentioned, octahedral or granular crystals, internal replacement by red earthy hematite. Sometimes it may coexist with specularite. Specularite is a particular type of hematite, platy hematite. It forms by subsequent metamorphism. And residual magnetite, of course, which is found as incompletely replaced veins. So this is overview of martite. I hope it is good enough. Thank you.